Okay, so during office hours today, we were talking about this question, and there was just not some confusion, but I want to provide a little more clarity for what's going on here. So consider this limit, the limit as x goes to 0 from the right-hand side of x raised to the 8 over x. So by direct substitution, what we're going to get here is 0 raised to the infinity power. Now the question is, what does this equal? Is this an indeterminate form? And I just want to clarify the difference between 0 to the infinity and infinity to 0. So right off the bat, infinity to 0, to the 0 power is indeterminate, while 0 to the infinity is not indeterminate. So first, let's just talk about what it means to be indeterminate. So, excuse me. We've seen 0 over 0, infinity over infinity. Now these are indeterminate forms. One way you want to think about indeterminate forms are when we have competing interests. So here, in the numerator, we have 0. So one way we can think about this fraction is we say, well, 0 divided by anything is always 0. So that means this must be 0, right? Another way of thinking about this, though, is that anytime we have 0 in the denominator, we say that this is undefined. Or if we're taking limits, it's going to go to infinity. So what wins out here? The fact that this fraction is equal to 0, or it's equal to being infinity or undefined. So that's why something is indeterminate. We have kind of competing rules here. So back to infinity raised to the 0 power. Why is this indeterminate? Well, specifically, we want to think about this in terms of a limit. So as x goes to 0, let's say I had 1 over x raised to the x power. By direct substitution, this would get us infinity raised to the 0 power. Well, let's think about each of these separately. When we're talking about limits, we want to look at each function separately. So we have 1 over x, and then we have x. So the 1 over x, what we're saying is, well, when we input 0 into that function, that is getting closer and closer to infinity. However, when we raise that function to the 0 power, we end up with infinity to 0. And this just means that this limit, we don't know what's happening to this limit. The base function is going to infinity, but the exponent function is going to 0. So you can think of this as saying, well, if I have a number that's going to infinity being raised to a number that's getting really small, well, that doesn't totally make sense, because anytime we have a base that's really big, we would say, well, it's likely that this whole expression is going to be getting really big. But if our exponent is getting really, really small, or basically 0, we would say, well, that's actually going to 1. So we have some competing interests here. But what about 0 to the infinity power? And a simple example of that is the limit as x goes to 0 of x raised to the x. Sorry. I meant to write x to the 1 over x. So by direct substitution, here we're going to have 0 raised to the infinite power. But again, because this is a limit, let's think about what's actually happening. This is saying is, as x goes to 0, the exponent here is going to infinity. So when I have a base number that's getting really close to 0, or essentially 0, a really small number, no matter what I do, no matter what exponent I raise that to, if I have a really small number, let's say it's that, and it doesn't matter how big my exponent is, this whole expression is getting smaller and smaller. So think back to exponential functions. If I have b to the x as my exponential function, if b is greater than 1, then this is increasing. If b is between 0 and 1, it's decreasing. right? If we're multiplying some number that's between 0 and 1 over and over and over and over again, that is just getting smaller and smaller. So if we do that an infinite number of times, this is just going to 0. So anytime we have, it doesn't matter what our base number is, it doesn't matter what our exponent is. If our base number is getting closer and closer and closer to 0, that is always going to win out. So this is what this limit is equal to. So all of that to say, this is not an indeterminate form. So we would select that one. There's no way we could ever apply L'Hopital's rule, even though it's not only is it not in one of these indeterminate forms, it's not in any indeterminate form. So it doesn't apply, and then we could just see that the limit is equal to 0. And you can verify this by looking at the graph, and I encourage you to do so. And if we saw the graph, we would see that it starts out really close to the x-axis, and then it balloons. So we can see that as we're getting closer to 0, from the right-hand side, we're approaching 0 there.